Welcome to video 12 of tasks in Scala. Once again, we're going to mainly do consolidation with a few details here and there, and we're actually going to start with one of the details, which is something you will be needing later on. Let's say we have a list of a few strings. Hello, you, there. Now we can do something fun. We can glue the strings together as follows. We say list dot make string, and then whatever we pass on here will be put between the strings. So for example, if I put a dash, let's print this result. It says hello dash you dash there, and this is one string. So from the list of 3 separate strings, we made one string with the function makeString. And this is just something fun that Scala gives us that we can use. So we could also just put a space, and then it prints hello you there, or we could put a new line, and then it puts the hello you there on 3 different lines. So this is a little fun something that we will be using later on. Now I haven't told you what the task is going to be, but I will tell you afterwards. I guarantee you it's going to be a lot of fun, and we are going to do a task together right now that is very similar to what you will do. So it will make much more sense. So today we are working for Lunchroom Fuentes that serves delicious paninis and pies. And here we have the menu of Lunchroom Fuentes. There are paninis. It's pick and mix yourself. All paninis have the same price, and a person can pick the bread type, the topping type, and the different salad options. Then Lunchroom Fuentes also offers pies, namely the apple pie with or without whipped cream for $2 and a vegan brownie for $1.80. And finally, there are a few drinks. They're all just $1, lemonade, coffee, or fresh orange juice. Now, why did we get involved with Lunchroom Fuentes? It is to help out the kitchen receive their order. An order consists of a list of ordered items and a table number. And here there are 4 parts that we are going to do. First, we're going to create all the necessary classes. Then we are going to create 2 separate orders for table 12 and table 3. And we have to use our imagination for what they are going to order. Then this is the main function. Print the order neatly so the kitchen can receive it. And then there is a 4th part, which is mostly for fun, but will also be very helpful for you for your task later on, and that is to create a function that gets the total price for an order. So let's get started with the first part. Create the necessary classes. Let's just start thinking about what a table order will look like, and then from that we can go back a little bit, because a table order will have something like a list of items, and then in this list we would have an item, the thing that was ordered, and also the amount that was ordered, because you could order 5 coffees, for example, and we don't want to write coffee, 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 coffee. It would be much better to just say coffee and then 5. So it would be something like an item and then the number. So we get a list of tuples. And the other thing that we need is the table number, which will be an int. Okay, now of course, if I would try to compile it right now, it will not work because I have not defined what item is. So let me just comment it out, but then you know what we are working towards, okay? We're going to create the class item, and that is simply going to have a name. So it could be coffee, it could be panini or whatever, and it's going to have a price. That is the most basic concept. I did not make a case class out of this because a case class cannot be a superclass for a subclass. And of course, we are going to work with subclasses, as you probably already suspected. So let's start with the first item, paninis. We're going to create a case class, panini. And then if we look at the details, you have a bread type, a topping type, and salad options. Let me just copy the whole menu down so we can see it a little bit more easy. So we have the bread type for panini. We have the topping And we have the salad. And the panini is going to extend the item, and it's going to have the name panini. And according to the menu, it's going to have a fixed price of $4. Next on the menu are the pies. So we have an apple pie and a vegan brownie. And I'm going to make two separate case classes. The first one is the apple pie. And as we see, you have the option to do with or without whipped cream. So we're going to pass on a boolean for that. Whipped cream, true or false is going to be. And this one is also going to extend item. The name is going to be apple pie and the price is $2. Next up is the vegan brownie. Well, we don't have to pass on anything else. It's just a vegan brownie. So we're gonna say extends item vegan brownie and the price is $1.80. Let's try to compile this. And now we get an error. Case classes must have parameter list. Try case class vegan brownie with an empty parameter list or case object vegan brownie. So we don't need any parameters here, so that's why I left it empty, right? According to the message in the error, we have two options. Either we put the parentheses like this, or we make it a case object. Let's run that. And now it compiles fine. So remember that whenever we make a class instance, that is an object. So now we are already creating an object directly, which is fine because if we want to use a vegan brownie, we can just use this one. And there is no need to create a class and then a separate class instance because there is no extra information that we want to pass along. So I'm quite content with this vegan brownie. Don't let it confuse you. You could have also opted for the empty parameter list and you can still do that in your code, okay? Next on the list are the drinks, and here we see that all the drinks have the same price, but they do have a different name. So I'm going to create a class drink that will receive a name. And it's going to extend item. The name is going to be passed on and the price will be fixed. Why don't I make a case class out of this? Well, I can actually make case classes for the separate drinks. So for example, case class coffee is going to extend drink because the name will be coffee. And then the price is already in the drink, right? But we know that since we have a case class without any parameters, this is going to be a case object, okay? And we could do the same thing for the other two. We have lemonade, and orange juice. Now it is definitely not obligated to use the case objects over here. We could have also made the drink a case class and then simply made class instances. There's a small difference on the pattern matching and I'm going to show you that real quick just so you know. So it's also personal preference, I think, in this case. For example, if we would make a function that is this coffee, and we would input a drink and get a boolean. And of course this is a silly function, but it's just so we can do some pattern matching on this and I can show you the difference. Say we match the drink. In this case, when we are using the case objects, we can say, well, if the case is coffee, this one, then the result is true. And if it's any other case, then the result is false. So let's test this. Is this coffee? We're going to test it with coffee. So you can use this case object just like this. It might look a little bit odd in the beginning because we're so used to seeing whatever we put into a function with a lowercase letter. But in this case, it of course has a capital letter because it's a case object. And then below that, I'm going to do, is this coffee with lemonade? I'm not going to print it. It's just going to show up right here next to the function calls. And as you can see, this one will return true and this one will return false. So in this case, you could do the pattern matching directly on the case object. Now let's look at the other situation that I was talking about. Let's say we don't want to have these case objects at all, and we would have just made a case class of drink. And then what we would have to do if we want to have coffee, we just say, well, drink with the name coffee. And the other drink would be, for example, lemonade, which is a drink with the name lemonade. And then this function would have to change because, of course, this case object doesn't exist anymore. So now what would we pattern match on? We would pattern match on drink with the name coffee. We have seen this type of pattern matching before. So this is how it would work in the other situation. Now over here, you cannot even see it anymore. Let me just run this so this goes away. Okay, so now we're going to test this coffee and this lemonade. So I'm going to say, is this coffee with the two values? So now you see that we do need the lowercase word, of course. Is this coffee lemonade? Let's see. And it gives the right value. Okay, so it doesn't make any difference in the functionality itself. You just see it has a slight difference in how you would write the code. So I like to go right now for the option to use the case objects. As I mentioned before, drink cannot be a case class because then we would not be able to extend drink. So I'm going to remove this. Awesome. So we're actually at the point where we have created all the classes that we needed in order to uncomment the table order. So we have created an item and then we have extended item a few times, namely for the panini, the apple pie, the vegan brownie, and the drink. And from the drink, we have created various case objects, namely the coffee, the lemonade, and the orange juice. And also the vegan brownie is a case object. Now we go to the second part. We're going to create two orders, one for table 12 and one for table 3. So order 1 is for table 12. This is going to be a panini, a vegan brownie, and a coffee. Let's start with the panini. It's going to be a panini with the type multigrain bread, then as a topping mozzarella, I think you write it like this, pesto. This makes me quite hungry, and then lettuce and tomato. Next up we have the vegan brownie, which is equal to, oh, of course we don't have to create a value of this because vegan brownie is already a case object. So we could write this, but it's just writing it double. It's just saying, well, this is exactly equal to this, so why wouldn't we just use this one directly? That is exactly what we're going to do. I'm just going to comment this out. And then a coffee, well, it's the same with coffee. We already have a case object for it, so we don't have to write anything else. That's very convenient. Now I'm going to create this list, the list of tuples of an item with the amount of ordered things. So over here we just have one of each, right? So that's going to be quite easy. So we're going to create order 1 items list. The first tuple is going to be the panini and then 1, and then I'm going to create the second tuple, which is the vegan brownie, also one of them, and then the coffee, also 1, and then remember that at the end we have to put the nil. So this creates a list. Remember that we saw these funny 4-dotted gluey thingies in the tutorial about lists. So if you forgot, you can always go back. Great, now we can create our order 1, and that is a table order for which we use the order items, and we use the table number, which is 12. And here I can do the same thing that we did before with the booleans. I can just give it a label. Table number is 12, so I don't get confused what we're really talking about. Awesome. Now we're going to continue with the second order, and this is the order for table 3. It's going to be 2 coffees and 2 apple pies with whipped cream. Now we don't need to define coffee anymore because we already have this case object that we can use. but we do have to define the apple pie with whipped cream. Apple pie with cream is going to be the apple pie, and then whipped cream is true. Now we can create the list of order items just like we did over here. So it's going to be order 2 items, and the first tuple is for the coffees. So it's coffee and the number is 2. We glue that together with the apple pie with cream, also 2 times, and then at the end, of course, the nil, the empty list. Now we can create order 2, which is a table order with the order 2 items, and the table number is 3. Okay, let's compile this, see if we don't have any. Uh-oh, yes we do. Oh, and here there's another typo. Thank you, compiler, for checking my spelling. Okay, so we have completed point 2 to create the 2 orders. And now we're going to continue on with point 3. Print the order neatly so the kitchen can receive it. So it's going to be something like this, what the kitchen would want to see. New order for table 3, 2 times coffee, 2 times apple pie with whipped cream. So what we will do is define a function that's called print order for kitchen, and it's going to receive a table order, and we're going to print something. So then in this case the return type is actually something that we call unit. So whenever it doesn't actually return something but rather does something like printing, then it's a unit. Okay, now you actually don't have to write this down necessarily, just like it's not necessary to write down the type of a value. For example, over here order 2 is of the type table order, but we didn't write it down like this. We could have, but we didn't have to, right? And it's the same with functions, but I do like to add the return type because it just makes clear what the return type is, and it will check you. So if you think, well, I'm going to return a string, and then in the code you actually return a double, you can be checked on that if you write down the return type. So if you do a print, the return type is unit. Now what we will do is define the message first. So there's going to be some sort of string here, and then we're going to print the message. Awesome. So the first part is new order for table 3. So let's start with that. It's going to be an interpolated string, new order for table, and then we grab the table number out of the table order. We do that with the brackets, the curly brackets, sorry, table order, and then the table number. So this would print new order for table 3, for example. Now we're going to move on to the part where we want to print all the different items. And for this, we're going to write a helper function. So we keep our code compartmentalized and clean. So we're going to create a function that will only create this as a string, and then we can add it to what we already have. So I'm going to say get items in string, and the input is going to be the list of items, which are tuples. Remember, so this is what we have in the table order over here, and this is what we want to print right now. So that's going to be the input, and the output is going to be a single string. We are going to map the items, and remember that every item is a tuple. We want to create from every tuple one string, something like this. So we're going to pattern match. We have the item, and then we have the number, right? And then we want to print an interpolated string that will say number times, and then the name of the item. And here I wrote the X with a space in between, but that is not what we want if you look over here. So what we have to do to be able to put it right there is add some brackets. If we don't do that, then this is going to read as one thing. And then the compiler is going to be, I don't know what NRX is. So we have to put the brackets here, and then it will substitute this part with the actual number, and then it prints the X, and then we get exactly what we saw over there. After this, we will have a list of strings because every tuple in the items list is mapped to a string, but what we want to return is a single string. And now we're going to use this nice little trick that we saw over here. We're going to use exactly this, the make string, and then in between the new line, so we get every item printed on a new line. Kind of like magic, right? Like this. Awesome. We can just test this out. Let's print an example. We say get items in string, and we just try it out with, for example, the items that we have over here. Let's run it. And it prints 2 times coffee and 2 times apple pie true. Okay, so this is close to what we want, but not completely, because I wanted to see apple pie with whipped cream. Now this makes sense, of course, because apple pie, as we can see over here, is a case class, and it's simply going to print the name of the case class and then whatever the parameter values are. So in this case it would be apple pie true. Now I would like this to be a little bit prettier, so I want to override whatever decides that this is going to be apple pie true. And whatever that is actually the method that is called toString. So we're going to override this, the toString method, which returns a string. And this is a method that all classes have. And for a case class, this prints something that's quite beautiful. And if you recall that for a normal class, let's say, it prints something that's kind of not that beautiful. It's more like an ID. But you are always able to override the toString method and just print whatever you think is nice. So that's exactly what we're going to do now. I'm going to say, well, if whipped cream, so if whipped cream is true, then I want to return apple pie with whipped cream. And otherwise, I'm just gonna print apple pie. So we did an override of the toString method, and then we said, well, if whipped cream is true, then we want to return apple pie with whipped cream, and otherwise we just want to return apple pie. Let's try this out. And now we get the 2 times apple pie with whipped cream. Perfect. Okay, so that was just to test our helper function. So this was a helper function. And now we're going to use this helper function over here, because we only created the first line of what we want to print for the kitchen. That was this. Oh, I forgot the double colon. Let's add it. And then there's a new line. And then we want to add whatever comes out of this. So we're going to say get items in string, and we're going to pass this function the items from our table order. Okay, so this is going to be one big string with all those new lines in between, because we added the new lines already. And then it's going to print that complete message. So let's just try this out. Print order for kitchen. And we're going to print order 1. Oh, print order for kitchen. I wrote down print order for kitchen. And this is what it prints. New order for table 12. 1 time a panini, multigrain, mozzarella pesto, lettuce and tomato, 1 vegan brownie, and 1 coffee. I have to say, that looks quite amazing. And now we're also going to print order 2. And it prints new order for table 3, 2 times coffee, 2 times apple pie with whipped cream. Well, that just makes me really happy, and I think the kitchen would be happy too. Now that was the main function that we had to create, but we're gonna create a fun bonus function that will help you also for your task later. And that is part 4, create a function that gets the total price, which is a double for an order. So let's just talk about this first a little bit. We have a table order, right? And within the table order, we have a list that is called items, and it consists of tuples, which is the item and then the amount that has been ordered. So this is basically what we are gonna wanna do. So what we have is a list. For example, we have coffee and then 2, and apple pie and then 2. This is not exactly how it would be written, but you understand what I mean, I think. So you have 2 tuples in the items list. Then what you would have to do is For example, step 1 is get the price of coffee and then multiply that by the amount that has been ordered, namely 2. And then you would know the total price for the coffees that have been ordered. And then you would want to do the same thing for all the items in the list. So for the apple pie, you want to grab the price and multiply it by the amount that has been ordered. And then for each tuple, you would get the total for that specific item. And then finally, of course, to get the total, you would want to sum it all up, right? So first, we're going to check out how would you sum up a list like that. That's extremely easy. For example, if you have a list with some random numbers and you want to know what is the sum, you just say numbers dot sum. That's all. That's how easy it is. Let's print that. And it prints 11 because 2 plus 8 plus 1 is 11. So at least we know how to do this last part. If we would have a list with all the numbers, then we can just sum it up with this very difficult dot sum. Now let's start creating the function. It is called get price for order. It will receive a table order. And the answer is going to be a double, as was stated over here. So from the table order, we're going to grab the items. Then we have a list of tuples. Now, from each tuple, first we're going to pattern match on it. We're going to say we have an item and the amount that was ordered. And then what we want from the item is the price. And we want to multiply that with the amount that was ordered. Ordered. Let me make this ordered. So if we do this, what do we have? From the table order, we get the items. That is a list of tuples. And then we're going to map each tuple to a double. So this gives us a list of doubles. And we want to sum up that list of doubles. So the final thing that we do is sum. And I wrote it down like this, by the way, but you don't have to. You can just write it all in one long line if that is what you prefer. But I think it looks very clean and easy to read like this, because you can just see, well, we start over here with a list. Then on that list, we do a map. Then we have a list of a different type, namely doubles, and then we can sum them up. Let's test this. Get price for order, and let's try that with order 1. And it says value price is not a member of item. So let's go back to item. Over here, item is a class, not a case class, so that makes the parameters by default private. That means we cannot just access them like this. So we want to access the price, so we can make it a value. Then it becomes a public parameter. Let's run it again. Oh, and I didn't print it, so it just shows up right here. So you can see that the total is $6.80. I'm gonna put a print line around it. Yes, now it's printed over here. Let's also print the second order, the total, and the total is $6. Well, that is easy to check because the second order consisted of 2 coffees and 2 apple pies. And if we go back to the menu, then the apple pie is $2, so 2 apple pie is $4. And a coffee is $1 and 2 coffees is $2. So together that would indeed make $6. So our code is amazingly great at calculating. Thank you, code. Okay, well, that sums up what we were gonna do together. And now we're gonna take a look at what you are going to do by yourself. Next to Lunchroom Fuentes, we find Bakery Gonzalez that wants to use our programming services as well. Well, actually, your programming services. They sell different items of bread and pastry, and you are going to help printing receipts for the customer. And here you have the menu. So you have loaves of bread, they are $2. There are 2 different varieties. You have a baguette of $2, coffee pastry, for which the filling is either apple or cherry, and you have cupcakes, and they have a vanilla or chocolate flavor, and they have with or without creamy topping. Now, the bakery is prized for their personal attendance to the customer, and that's why a receipt will look something like this. First, you have a line that says receipt Bakery Gonzalez. Then you list the different items with their prices. This price is just for one item, and here you state how many of those items somebody has bought. Then at the end, you print the total. Then you also print by whom they were attended. And finally, have a great day. So this is the whole receipt, and that is what ultimately you are going to be creating. Let's put that into some different steps that you will be doing. First, you're going to create all the classes for the menu items and a case class for bakery order. And a bakery order contains a list of bought items, so the item and the amount. It's quite similar actually to what we did, and the name of the employee that fulfilled the order. Then part 2 will be to create 2 orders with different items. One is going to be fulfilled by Abby and the other one by Dan. You have to use some imagination for that. Part 3 is to create a function that gets the total price for one bakery order, and this is going to return a double. And then we get to the final and most important function, number 4, and that is to print a receipt for a bakery order, just like the example that we saw here. And to achieve this, write a helper function that creates a single string of this specific part where all the items are listed. And then for this part, 2 small comments. So don't forget to print the total as well. I can imagine that once you have printed this, you're like, hoo-hoo, I'm done. But no, don't forget to print the total as well. And for this, you're going to use the function that you created in the previous step. And finally, it's okay to print the prices like this, like $2.0 instead of $2, because of course we are working with doubles and we already know how Scala prints that. You can see it right here as well. Okay, so I'm very excited for you to help out Bakery Gonzalez with their receipts. I hope you have a lot of fun. And this is the last video of this first series of tasks in Scala. I hope you had a lot of fun like I did. I hope you learned a lot, and I will see you in any next series that will come up.